In today's video, we'll be learning about the power rule of calculus. To start off, the power rule of calculus is that n times x to the n minus 1 power is equal to the derivative. So, the derivative is equal to n times x to the n minus 1 power. And before I go more in depth in the power rule, we'll first try to prove the power rule. So let's just take some expression x squared, right? And then if we apply the power rule to the x squared, we'll get 2 times 2 minus 1 is equal to 2x. So this is our answer. Derivative is equal to this equation here. We'll get to more examples later, but for now, you can only use the power rule for polynomial functions, and that's very important. Polynomial. Which means that e to the x power, ln x, logarithms, these are all invalid expressions you cannot use. So now, let's get into more depth of the derivative. So, in order to prove the power rule function, I will now go back to the algebraic form of the derivative, which is the derivative is equal to ln of, as h approaches 0, of some function f of h minus f of x over h. And we'll just do it on the same expression. So we know that lim of h approaches 0 is equal to x squared plus 2xh plus h squared minus x squared over h. And all I did was plug x plus h into x squared, since that's the definition. Now this is equal to 2x lim of, as h approaches 0, of 2x h plus x squared over h, and then we have lim as x approaches 0 of 2x of h, and then this is equal to 2. This is equal to 2x. And that's actually and if we do the power rule way, which is n times x to the n minus 1 power, we get 2x 2 minus 1 is equal to 2 times x. So they both give the same result, which means that the power rule has been proven correct now. So now, I'll be giving you some problems to do, and take a moment and pause this video and solve these problems. So first off, we have, let's just say 3x to the 4th power plus x to the 3rd plus x, and then, sorry, let me make this do better, okay, 2x to the 5th power plus x to the 4th power, then we can do 2x to the 4th times x to the 4th power plus 2 times x to the 3rd power. And then we can do x plus 1. Yeah. So take a moment to solve these equations, and yeah, so this is 2, yeah, okay. Take a moment to solve these equations, and yeah, I'll solve them after you're done. Okay, so here's how you solve them. So for this equation here, we first want to do 4 times 3, which is 12, plus 3 times times 3 times x to the second power plus 1. And so why does x become 1? Well, we know that it's x to the first power technically, right? Which is then equal to 1 times x times 1 minus 1. x to the 1 minus 1, which is then just equal to 1 times x to 0. X to 0 is just 1, so it's just 1. That's why it's just 1. And for this equation here, we just applied the power rule, right? 5 times 2 is just 10. 5 minus 1 is just 4. So this x times x to the fourth power plus 4 times x to the third power. Now we do 8 times x to the third power plus 6 times x to the second power. Here, remember, x is just 1. And what is 1? What is the derivative of 1? Well, the derivative of any constant, right, du over y, of constants is just equal to 0, which means that the answer here is just 1. So these are all the answers. So did you get them right? Oh, hopefully you did. Okay, so now we'll do some more practice. But this time it'll be somewhat harder. Okay, so say for example you have an equation like this, expressions like this, right? 1/2 times x to the fourth power plus 3 over 2 times x to the fifth power plus, we'll just say 4/5 times x to the second power. Now, this is how hard power rule gets, right? This is probably the hardest, most difficult power rule problem there is. Or yeah, there's difficult power rule problems, but this is like one of the fraction power rule problems are probably one of the hardest, most difficult power rule problems there are. Fraction power rule problems. So this is just equal to, right? The derivative is just equal to, well, 4 times 1/2 is just 2, right? And then 4 minus 1 is just 3. Plus 5 times 3/2 is just 15 over 2. And then 5 minus 1 is just 4. And then 2 times 4/5 is just 8 over 5. And then 2 minus 1 is just 1. So we just get x. So then this is our answer right here. A over 5x, so 2x to the third plus 15 over 2 times x to the fourth power plus 8 over 5x. Okay, so that was the power rule problem, and yeah, the way of doing power rules. And now I'll see you in the next video, which will be more in depth of calculus. Alright, see you next time.